Hello, ladies and gentlemen. Mr. Tao here, and what we're going to do now is take a look at pollution problems with groundwater. And groundwater is one of those really difficult things to clean up, mainly because it's so hard to get there. I've never been there, and so if I haven't been there, you know that very few people haven't been there because your teacher travels to all places on Earth that I can possibly get to. Well, anyway, on to what we're going to be looking at today. Pollution and groundwater. Well, what is the big deal with groundwater? As we said just a minute ago, cannot cleanse itself readily. It's hard to get there. So when a pollutant gets down into the groundwater supply, it's going to be very hard to get it out. Common pollutants include fertilizers, gasoline, organic solvents, and these wide plumes happen once it gets down in the ground. And what do I mean by that? Well, remember the magic formula is one gallon of an organic pollutant can contaminate up to 10 million gallons of groundwater. It's very slow, less dissolved oxygen. There's no bacteria. There's just nothing down there to help clean it up, right? So we think of things such as DDT, which is a pesticide, or other metals and nonmetals such as lead and arsenic as being in our groundwater supply. Really, groundwater has been poorly regulated compared to other water sources in the United States over the course of history. It's only recently that groundwater has really come into the focal point of regulation. So where does it come from? This graphic really sums it up quite well. Everywhere from landfills that are leaking, with open lagoons, which you can see right here. That's a big deal in some areas. Also gasoline stations with buried underground tanks, and perhaps in your travels you've gone by a gas station and one day you notice it's closed and there's big piles of dirt there covered up with plastic. Well, it's probably because there was groundwater contamination. They had to change those tanks out. And once upon a time they made all those tanks out of metal rusts, and today they make them out of polyethylene. So that helps to limit the amount of rusting and leaking. So here we have an example of a leaking gas station like we were just talking about, right? And so the EPA estimates there's at least 100,000, little typo there, 100,000 leaking tanks in the United States at any given time. A lot of times we don't know that they're leaking until it ends up someplace else, such as fumes in somebody's basement, or they get a smell of gasoline in a nearby well. And it's very expensive to clean this up. We're going to take a trip to a Superfund site in just a minute that I'll show you. We go ahead and look at where groundwater pollution is such a serious threat. Well, China, mainly because of a lack of environmental regulation, and the leaking underground storage tanks. The more storage tanks you have, the greater the risk. And we talked a little bit about gasoline and oil, about this methyl tertiary butyl ether. Well, I have a video clip that I'd like you to watch, a little documentary on MTBE at the end of this that explains what the issue is. So MTBE, in short, was a replacement to leaded gasoline. Leaded gasoline was invented because it helped cars run more efficiently. When they discovered that lead was a poison, they then had to take it out of the gasoline, starting in 1979. They replaced it with oxygenated fuel known as MTBE. However, after 10 years, they slowly discovered that MTBE was actually more poisonous than lead. The MTBE has been taken out of our gas since then. It's been out of the gas for about 10 years now, and replaced with ethanol. The next time you go to the pump and fill up, you're going to see that the gas contains 10% ethanol, again to help engines run more efficiently. All right, arsenic. Arsenic is a natural substance found in the ground. It's a poison, and as we look at groundwater, it's not that more groundwater perhaps is contaminated now than ever in the United States, but we're just better at testing for it. In fact, the Orange County Water Authority now tests hundreds of wells in Orange County through a program called Get Wet. It's a volunteer program, and they're looking at patterns in groundwater pollution. So we're looking more at it closely than we ever have before. And arsenic is one of those naturally occurring substances in the ground, just like uranium. So basically, prevention is obviously our best solution to groundwater cleanup and groundwater protection. So here's some solutions to that. Obviously find less toxic substances, keep chemicals out of the environment, use monitoring wells. A monitoring well is what you see right here nearby, so that any pollutants that you can tell if there is a leaking source. And actually landfills have to have monitoring wells all around them, right? Groundwater pollution solutions, right? There's many ways to purify drinking water. We've talked about this in the past. We've been to a drinking water plant. We've talked about desalination. Maybe the answer is nanofiltration. Then there's these life straws, which is a great invention, right? In a lot of lesser developed countries, there are organizations that are trying to provide these to people. They essentially have a nanofilter in them that allows you to drink surface water. New York City's water supply, very unique. And that New York City relies mostly on surface water. That surface water is not filtered, right? So when we think about prevention of groundwater and other water pollution problems, really the best case example of that is New York City. New York City has spent millions of dollars buying property around their watershed and thereby protecting the forests from development, and they've completely avoided the need to build a big purification plant. And really, they've prevented the pollution from their drinking water supply in the first place. So that's a classic case of prevention is our best solution. The U.S. Safe Drinking Water Act in 1974 was the first time that we had anything on drinking water levels that could affect human health. Health scientists say that it's still weak and that it should be stronger. Your water polluters don't want to deal with it because it's going to mean that they have to tighten up their regulations. So is bottled water the answer, right? We've talked about bottled water. U.S. has some of the cleanest drinking water as it is, yet we buy more bottled water than anybody else. Bottled water, some of it's from tap water. Dasani comes actually right out of the Newburgh City Aqueduct, right here in Orange County. If we think about that, when you buy Dasani, what are you really buying? You're buying water that's been purified out of the aqueduct. If we think about the fuel cost to make plastic bottles, the waste that's produced, probably not worth it. So here's the video on MTBE pollution, and I'm near the end of this. So what I'm going to do is I'm going to end this slideshow, and I'm going to go to another slide that will then show us a little bit about a site in Orange County, Consolidated Iron and Metal. So this was a site that was afflicted with groundwater pollution. And this is what it looked like prior to the EPA cleaning it up. Basically, this site was a place where they would bring in cars and they would crush them. And in crushing them, what they would do is they would just leave whatever fluids and oils and things like that are in the car. And it would run through the crusher. And then once it goes through the crusher, all of that material would come out. So I'm talking about antifreeze, maybe residual gasoline, car batteries. Then they would run it through the crusher, and then they would smelt that. You can see the smelter in the background, right? There it is. So we had like ash dumped on site. There was that stuff that came out of the crusher. And now this site was rendered useless. So you can see here that most of the site was initially cleaned up. They got rid of the surface material, but there was about 10 feet thick worth of contaminated soils with lots of organic substances. The way that they found this was that there was a kayaker on the Hudson River that noticed a blue ooze coming out of the shoreline, and that happened in about 2004. And the Department of Environmental Conservation went in to check, and when they checked, they learned that there was contamination at this site. So how do we clean it up? Well, all of that material had to be excavated out of there, and they drilled these wells in the ground so that they could see where the pollution is. And once they get an idea of how big the plume is, then they know what the job is ahead of them. So step 1, remove the contaminated soil. Step 2, remove the contaminated groundwater. And that involved pumping the groundwater 24 hours a day, 7 days a week, 365 days. And that project is going to go on for probably a decade or more of pumping groundwater. And that goes actually now to the Newburgh sewage treatment plant, where they can handle some of those contaminants. Luckily, the treatment plant is nearby. And the whole goal is that the site will be able to be used for something. So here you can see a monitoring well right there. And that's where they go ahead and they sample from and also extract groundwater so it can be cleaned up. Chain link fence all the way around the outside, handled by the U.S. Environmental Protection Agency, the Consolidated Iron and Metal Superfund site. Okay? And there's just another shot of that site. This is actually where the crusher was, and the trucks would come in on a scale, and then the crusher was located right over here. So what does it look like today? Well, if I go to Google Earth and I zoom in on Newburgh, New York, I can go down to Google Earth and I can see right on the coast, just down the road from the Newburgh waterfront, coast of the Hudson River, I'll be able to find Consolidated Iron and Metal. How do I know? It's this nice greenway right here. Now this site was cleaned up in 2011, I believe. So I can turn on the history here and we can see what it looked like in the past, right? So if I go back in time to 1994 and look at this site, give it a second to load. I can see actually in 1994, look at all the junk cars here. This is all junk cars. The crusher's in here, right on the banks of the Hudson. And luckily, nobody nearby, because this is an industrial area, used this for their drinking water. Luckily. Right? As I go through time, and I can go ahead and look a little bit more, I can see that indeed, here is a lagoon open to the elements, just filling up with water and contaminants. If I go down here, I can see that in 2001, the site was almost now extinct at this point. Down here, this is interesting. This is where they would actually just take extra metal and extra parts that could not be smelted or scrapped. And they'd literally just dump it into the Hudson, right? If you look at this site, you see how this comes out like this? This is all landfill. The original coastline goes right like this, right across here. This is all just landfill debris that's been dumped in there as a result of their project. Let's go ahead and go a little bit more ahead, and we can see what the site looked like in 2004. And then in 2006, this is prior to remediation, and go ahead a little bit more. And we'll see that the EPA got in there and did do some remediating. Now the lagoon is kind of filling up there with trees and things, and voila. 2011, with the goal that hopefully this site can be reused. And you can see that they did some bank restoration in here, and it looks pretty good. In a future topic, we'll talk about how this was paid for. It was paid for the Environmental Protection Agency Superfund program, which you are free to go ahead and Google on your own. Well, that ends this screencast on groundwater pollution. I encourage you to watch the video on NTBE and make sure that you look at the checkpoint questions in this section of the lesson.